section's on 2.3 continuity. So we're going to go ahead and talk about the 4 different types of discontinuities. So one of them is called a removable, and we've actually seen something like this where it's a linear equation, and then we called it a whole when we did 2.1 and 2.3, but it actually is called a removable discontinuity, and then the graph continues on. And so normally on the graphing calculator we had an error, we had to check in the error if it's a vertical asymptote, or back then we called it a whole, but now we call it a removable discontinuity. The other one we have is this one right here. Same thing, it's a linear equation, there's a removable right there, and then there's also a point. So at that point right there, normally this graph right here is drawn through piecewise graphs. Okay? So then the second one is called a jump discontinuity, and a jump discontinuity is the same thing as a regular graph, except we actually have to jump. So I would normally say if you draw a graph right here and you have to pick up your pencil to continue on, then that's probably most likely going to be a jump discontinuity. And normally this jump discontinuity is found through a piecewise graph. So we do number 3 is the infinite discontinuity, and then infinite discontinuity is something like this where we have some kind of discontinuity as we learned in the last section, but in this case there's going to be infinite where these guys go to infinity and these guys go to infinity, so that's called an infinite discontinuity. Okay? And then the last discontinuity type is called the oscillation. So the oscillation is going to be something like this, where it actually oscillates and then it stops. You got to pick up your pencil and then continue on. So it's similar to the jump discontinuity. The only difference is that this is actually oscillating, whereas the jump discontinuity does not oscillate. So that's the difference between those two. Okay? So now knowing the 4 different types of discontinuities for today's classwork, we're going to go ahead and do the examples of something like this. So we have y equals 1 over x, and they're going to ask us to look at 3 different parts. One of the part is called a point of continuity, so you got to describe all the places where it's continuous. Part B is asking us to find the points of discontinuity, if there are any. And then also part C is asking us to identify the types of discontinuity. So 1 over x should be the hyperbola as we know, this graph right here, the hyperbola. Okay? So part A is asking us to find the points of discontinuity. This part right here will go on to negative infinity all the way up there, and this is going to come out to all the way out here to positive infinity. So technically this graph will go like pretty much all real numbers because they will continue, but then there's a discontinuity right there. So in this case, and then it picks up and then goes all the way up there. So for part A, it says points of continuity is all real numbers except when x is equal to 0. For part B, it asks us to find the points of discontinuity. So as we mentioned in part A, it's obviously at x equals 0 because that's where the graph is discontinuous at, right there. Okay? So and then part C is to identify. So at the discontinuity, we have to then identify which 4 it is. So this one is going to be obviously infinite because this is going to negative infinity and this is going to go to positive infinity. So that's called an infinite discontinuity. Okay? Now, example number 2. Now be careful of the radical right here because normally when you have a square root, you cannot take a square root of a negative. So in that case, your graph is going to stop somewhere. But when you have a cube root, and you actually can take a cube root of a negative. So in this graph right here, it looks something like this. It's going to be pretty much part A, find the points of all the continuity. This is all real numbers. There is no whole or removable in this case. There is no vertical asymptote or anything like that because we can take a cube root of a negative. So just be careful of that one. Part B, so since there is no discontinuity, so then obviously we will say none on the points of discontinuity. And then part C will ask us to identify, so obviously we'll say none as well because there are no discontinuities in this case. So I purposely chose this one because in the square roots and the cube roots they're different. The square roots will have some discontinuities, but in the cube root there is a possibility that you will not have a discontinuity. Okay? So let's go ahead and try the classwork now.